Hello everyone. In this session we are going to discuss about problems on classification of soils. We'll quickly revise first what all we have studied with respect to classification of soils, and then afterwards we'll pick up some problems and then discuss about them. Okay, this chart already we have seen and discussed in length, but just to go through, the soils are classified generally as gravels, sands. Next is silt and clay. The gravels are particles which are greater than size 4.75, and if the particles are between 4.75 and then 75 microns, then they are called as sands. And then group symbols, depending upon the other criteria, they have gravel well graded, gravel poorly graded. Here we have to see that the fines are less than 5%. If the fines are in the range of 5 to 12%, more than 12%, then they may be classified as silty gravel or clay gravel. Similarly, over here, if the fines are less than 5%, then they are pure sands, sand well graded or sand poorly graded. If the fines are more than 12%, then it will be silty sand and clayey sand. So like that the classification goes. This already we have seen. A soil has to be sieved through 75 microns, and then an example 650 is retained above. It's a coarse fraction referred to as, and then the passing through is 350 grams. That is fine fraction. It will be fine part or fine fraction. Then comparing the two parts, because it is coarser than 75 microns, more than 50%, the whole soil is classified as coarse grained soil, and it can be either gravel or sand. Now that upper coarse fraction is taken and then sieved through 4.75 sieve, then let us say that something like 400 retains above and 250 grams goes through. In such case, the coarse fraction is more than 50%, larger than 4.75, then we call that it is a gravel. Then we have to do the sieve analysis or grain size distribution analysis, and then go for searching for the second letter over here, whether it is GW, GP or something like that. Okay, again the similar kind of analysis. Here also it is a coarse grained soil. Next is we have to sieve it through 4.75 sieve, 4.75 sieve, and suppose by chance only 250 grams is retained above and then more than 50% passes through. In such case it will be classified as sand. Okay, then to find out the next letter of classification, that is SW, SP, SM, SC, you have to do further analysis. Particle size distribution curve already we have seen. Here with respect to 4.75, 92%, this tells that particles finer than or lesser than this particular size 4.75 are 92%, that is to say 8% are gravel. Like that the analysis goes. So gravel is 8%, fines are less than 4%, 4%, so obviously remaining is sand. As percentage of fines is less than 5%, it is pure gravel or pure sand. So determine CU and CC depending upon their values. It can be well graded or poorly graded. Okay, here fines are more, 16%. That is the major difference. Otherwise, everything else kept the same. So percentage of fines is 16%. Because of that, sand is 76%. But still, 76% is sand, and then gravel is 8%. Because of that, the overall soil is sand itself. But only thing is, because of this fines, whether it is SM or SC, that we have to see. So if the percentage of fines is more than 12%, if the percentage of fines is more than 12%, the soil is gravel or sand with silt and clay. So now how to do that? Determine IP for the fines passing the 425 microns. If IP is less than 4, it is silty, and if IP is greater than 7, it will be clay. That's how the classification will be done. Okay. Again, soil is taken passing through 75 microns. If more than 50% passes through, then the overall soil will be classified as fine grained soil. Then we have to, from the overall soil, we have to take a soil which is passing through 425 microns, and on that you have to conduct Atterberg limits or consistency limits. Depending upon their values, you have to refer to plasticity chart to find out whether it is clay or silt or with what compressibility and all. Okay, here there is a plasticity chart. It's a ready-made chart. We have seen that there is important red lines. One inclined having equation IP equal to 0.73 WL minus 20. There are two vertical lines at WL equal to 35 and 50. Right. So in this region, if the soil falls, then it will be CL. In this region, if it falls, it will be CI, indicating clay with intermediate compressibility. In this triangular region, if it falls, then it will be clay with high compressibility. Similarly, in this region, it will be MHROH. In this particular region, it will be MIROR. In this region, it will be MLROL. And if it falls in this particular piece of area, then it will be classified as CLML. It is in between 4 and 7. I have told you that if it is less than 4, IP is less than 4, it can be taken as silt. If IP is greater than 7, it can be taken as clay. But 4 to 7, it is a transition. Because of that, it requires a dual symbol representing both clay and then silty properties. That's why the classification symbol is also CLML. Okay. Okay, here all that in a nutshell. Group symbols are GW, GP, GM, GC, SW, SP, SM, SC. Here it is, if it is well graded, then CU has to be greater than 4. If the sand is well graded, then CU has to be greater than 6. CC is between 1 and 3. Here also it is between 1 and 3. To tell that it is a silty gravel, IP is less than 4. GC, IP is greater than 7. Similarly, IP less than 4 is silty, IP greater than 7 is clay. Right? Okay. This is the first problem that I have taken from old question paper. So what is said is, classify the soil on the basis of the following data. What is the data given? There are 4 soils, A, B, C, D, and we'll take one by one. A, B, C, D. Okay. Now there is no liquid limit or plastic limit for D. You can just see here, right? And percentage passing through 75 microns plays an important role. So you have to look at these values also. percentage of gravel they have given, percentage of sand they have given, Cu and Cc is mentioned. Now here concentrate percentage passing through 75 microns is 10%. So to say, it is coarse grained soil. Even in this case also, percentage passing through 75 microns means more than 50% is retained above 75 microns. So very clearly the soil C and D, both of them are coarse grained soil, and then percentage passing through 75 microns is full 100% or 70% in both of these cases. Obviously the soil will be fine grained soil. That's why I have written C and D are coarse grained soils, either G or S, and A and B are fine grained soils, either silt or clay. Now starting with the bottommost, soil D, it is coarse grained soil, it is non-plastic, percentage of gravel is 10, whereas percentage of sand is 80. So comparing these two, I can say that it is sand because percentage of sand is more. Okay, now for sand, Cu has to be greater than 6, but it is 5, and Cc is 10. Even this is not satisfying the range of 1:3. So though it is a sand, it is not satisfying these two conditions. Because of that, it will be poorly graded. So soil D, it is sand but not well graded. Therefore it is poorly graded sands. That's why classification symbol becomes SP. Now soil C, if you take, okay, interestingly what they have given is liquid limit and plastic limit, but percentage of fines is 20%. Okay, now here percentage of fines is 20%. Because of that, what they have done is they have taken the sample which is passing through 425 microns and conducted liquid limit and plastic limit also, right? Now if you compare percentage of gravel, percentage of sand, 2060, right? So out of 80% left over, right? 2060. So more is sand, that's why it is sand. Okay, now though it is sand with Cu greater than 7 and Cc between 1 and 3, we cannot say that it is well graded or poorly graded sand, because percentage of fines is more here, that is 20%. So there is liquid limit and plastic limit, which gives you IP, plasticity index, which is a difference of these two. Here it is written IP is 40 minus 20, 20%, right? Soil C, it is sand. Comparing these two, it is sand, but appreciable fines are present. Because of that, it is IP is greater than 20. Obviously it becomes clay because it is greater than 7. IP is greater than 7. So straight away one can classify it as clay sand, SC. Okay. Now here I have calculated IP on A line, because A line has got an equation 0.73 WL minus 20. That value becomes 14.6, whereas actual value is 20%. Here I will try to make a sketch. Suppose this is A line and WL is 40, somewhere there. So it is between 35 and 50. Because of that, it will be of intermediate compressibility, But what we are searching is the value over here. This is calculated by the equation over here. So 14.6 comes somewhere there, but actual value of IP is 20, means the point is somewhere there. So to say, it is clay. Above is clay. That's why C is chosen. That's why it is sand with clay. Clay sand it is. Sand with appreciable amount of clay. Okay, we'll go for B. Now B, look at the percentages. It is more than 70%. That's why it is obviously fine grain soil. Percentage of gravel, percentage of sand, etc. is gone. But because the percentages are less, they play a less role. And again, liquid limit and plastic limit is 20. So I can calculate IP as equal to 20%. IP on A line is 14.6, just now explained. This is liquid limit is 40, so this value is 40. Corresponding to that, this value is 14.6, whereas actual value is more. Because of that, it is clay, and moreover it falls within 35 and 50. You know that there is a middle range 35 and 50. Because of that, it is intermediate. So it is clay with intermediate compressibility or medium compressibility. That's how we can classify soil B. Now soil A. Soil A, liquid limit is 400%, right? So IP becomes, you can just see here, 355 IP, and then IP on A line is 277.4. Obviously it is not less than IP actual, right? IP actual is IP on A line is 14.6. that's why it becomes clay only, because it is above A line. But WL is given to be 400%. So liquid limit, it falls in this region, beyond this region, but above. So that is the region where the soil will be falling. So because of that, it will be clay with high compressibility. CH would be the classification. Okay. Okay. There is one more problem. Following data refers to a soil sample of soil, percentage passing 4.75 mm, ISC is 64%. Readily one can say that percentage of gravel is 100 minus 64, that is 36%. Percentage passing 75 microns is 6%. Percentage of fines is 6%. That's why percentage of sand can be calculated, because it is 64 minus 6. Then you know how to calculate now. So 58%. So looking at all these values, it is sand, but percentage of fines is little more here, more than 5%, but less than 12%. So it is between 5 and 12%. Hence it is borderline classification. Now sand, for sand, Cu has to be greater than 6, Cc has to be between 1 and 3 if it has to be well graded. So what happens is, in this case it is sand fine, and coefficient of uniformity is given to be 7.5%. Coefficient of curvature Cc is given to be 2.7. So it is satisfying both the conditions. That's why it is well graded sand. Then also they have given IP which is 2.5, less than 4. Because of that it is silty binder, that's why it's SM. And because of that, this particular range, the soil is classified with the dual symbol SWSM. Right? It is well graded, fine, but it is having appreciable amount of silt also, and because it is a transition, it will be classified as SWSM. Okay. Here, can you match the list in 1 with the list in 2? List in 1 will see it is gravel well graded, sand well graded, silt with a low compressibility, clay with low compressibility. Okay. Now in the list 2 we have soil having uniformity coefficient greater than 6. If it is a sand, and then if Cu is greater than 6, we would have told that it is sand well graded. There is an option. One can go with B, or B will be with 1, but there are 2 more alternatives. Let us see. Soil having uniformity coefficient greater than 4. This can be gravel well graded. So A can be 2. So for A, alternate B and alternate C are giving 2 as the option. Again, there is ambiguity. The third one will say soil having low plasticity. Both of these are having low plasticity. Then soil have low compressibility. Low compressibility, both of them. Low plasticity is silt, right? So option can be the D should go with 4. D should go with 4. ML can go with 3. Yes, that is C with 3. Sand well graded, that will be 1 actually. So B21 is here. Two, 1, 3, 4. I think B would be the answer here. In this case, you can just check out whatever we have discussed. It is getting satisfied in this, because gravel well graded is 2, fine. BSW, that is 1, silt with low compressibility, low plasticity, C with 3, and then clay with low compressibility, soil having low compressibility is 4. I think that is an answer, right? Okay. Okay, based on grain size distribution analysis, the D10, D30, D60 values of a given soil are given. As per IS code, the soil classification will be, so it is sand only. The only thing is you have to find out whether it is SW, SP, or SM, or SC. To decide SM, SC, they have not given any data, but you can always calculate Cu. What is Cu? Cu will be equal to D60 by D10. D60 is this, D10 is 0.23, so 0.41 divided by 0.23, approximately 2. So Cu has to be greater than 6 for sand to be well graded. So obviously one can decide that it is Sp. Okay, it is sand. Anyway, they have given all sands. So poorly graded or well graded, that classification you have to do. Now Cu, if I calculate d60 by d10, it is coming out to be 2, which is less than 6, because for sand to be well graded it has to be greater than 6, but it is less than 6, that's why it is poorly graded. Okay, soil, sieve analysis on dry soil has on 1000 grams showed 850 grams and 250 grams of soil passing through 4.75 and 0.075 respectively. Now this indicates that 150 or 15% of the soil is gravel, okay, and 250 means 25% of the soil is passing through 0.075. That means there is an appreciable amount of clay or silt. Because of that, it will be silty or gravelly kind of classification. And percentage of sand is 850 minus 250, means how much it will be, around 60%. Okay, so here I can write gravel is 15%, it is becoming, because it is 85% lesser than 85%, lesser than 4.75 size is 85%, 850 grams gravel. And then fines are 25%, because 250 grams is passing through 0.075, that's why fines are 25%. And then now sand becomes between 85 and 25. 85 minus 25 is 60. So looking at the percentages, I can say that from this data I can classify it as sand. Now, is it well graded or poorly graded? SP or SW? No, fines are more than 12%. Okay. Now, further data, if you look at the liquid limit and plastic limit of the soil passing through 425 microns, 42 and 20. So from this I can calculate plasticity index IP, which is equal to 42 minus 20, that is 22%. Okay. When you got IP more than 7, obviously it will be clay, so it can be classified as the sand with clay binder. So that would be the classification. SC would be the classification symbol, not SM. If this percentage IP, if it had come less than 7%, 5%, 4%, less than 4%, then it would have been SM. So in this case it is not SM, it is SC. Okay, well, with this we'll stop. Thank you.